For most power plant operators, fuel expenditures account for 70 to 80% of production costs and millions of dollars per year. In fact, improving heat rate 1% could generate $500,000 in annual savings for a 500 megawatt power plant. To contain fuel costs, power plants must maximize the efficiency of their feed water heaters. That's why many companies today are focusing on improving heat rate as a way to use their feed water heaters more effectively and significantly reduce their fuel costs. Heat rate is a measure of how efficiently a power plant uses heat energy. You can measure heat rate by the number of BTUs your plant requires to generate a kilowatt hour of energy. As your heat rate goes up, so do your fuel costs.
Although a reduction in fuel costs through improved feed water heater level control has the most significant impact on a company's bottom line and their ability to compete in unregulated energy markets, the benefits go far beyond consumption and cost. For instance, a plant can realize a quantifiable reduction in CO2 and other emissions simply by improving feed water heater level control. Additionally, extended boiler longevity by eliminating overfiring to overcome shortfalls in final feed water heater temperature is also achievable. And of course, there is the public relations value in that a plant is pursuing all avenues to minimize negative impact on the local community and environment.
The condenser is the beginning of the feed water heater's process, where condensed steam from the feed water heater drains and HP, IP, and LP turbines is routed through successive feed water heaters. At the same time, extraction steam from your turbines reaches the appropriate feed water heaters and the transfer of energy takes place. Maintaining accurate and reliable level control throughout this cycle is critical to achieving the final feed water heater temperature that your process requires. Let's take a closer look at how this works. Feed water heaters use the heat of condensation to preheat water to the correct temperature for the boiler. During this process, shell and tube heat exchangers allow feed water to pass through the tube side and extract steam from the turbine to the shell side. The primary benefit of this process is that the feed water heater decreases the fuel costs by using recovered energy, rather than costly hot gas, to heat the water. Achieving optimum water level in a feed water heater is a critical component of maximizing energy transfer and minimizing controllable losses.
Precision control of the feed water heater during base load and cycling operations provides operators with the high degree of data certainty necessary to optimize the feed water heater condensing zone. This is important for improved heat transfer during the condensation process. This will have a profound impact on the final feed water heater temperature and ultimately heat rate, all without jeopardizing expensive hardware.
There are normally 6 to 7 stages of feed water heating. Making an investment in level control can help you achieve optimum heat transfer and improve terminal temperature difference to provide a significant return on investment. With Eclipse Model 706 guided wave radar, you can optimize the condensing zone of your feed water heater to deliver accurate level control, maximize energy transfer, and minimize undue wear and tear. This can help you generate the savings needed to recover your investment. Older level technologies, such as differential pressure, magnetostrictive, RF capacitance, and torque tubes, are vulnerable to process conditions and induced instrument errors, such as shifts in specific gravity and mechanical or electronic drift. In contrast, guided wave radar provides a truly reliable level measurement solution for feed water heaters. Magnetrol's new Eclipse Model 706 provides enhanced guided wave radar performance, virtually unaffected by process variations. The Eclipse Model 706 gives you a superior degree of accurate and reliable continuous level measurement without the need for calibration or gravity corrections. By combining superior signal performance and advanced diagnostics, the Eclipse Model 706 delivers premier level control for feed water heaters, as well as a broad range of challenging applications such as condenser hot wells, de-aerators, and cooling tower basins. The Aurora GWR and Magnetic Level Indicator package merges the operating system of a conventional float-based magnetic level indicator with the leading-edge Eclipse Model 706 guided wave radar transmitter. This allows you to effectively measure low dielectric media, high temperature, and high pressure process conditions and media with shifting specific gravity and dielectric values accurately and repeatedly. The result is a diverse and redundant level measurement solution in a single chamber design. Magnetrol's guided wave radar technology will improve your feed water efficiency and overall heat rate, and ultimately your bottom line. Contact us today for a free feed water heater survey and put the power of Magnetrol to work for your company.